Okay, hello everyone. Welcome to a slightly delayed and fairly short design review about our financial framework. Okay, what are we looking at here?
So we were still finishing up some of the last design things for the Monte Carlo simulation methods. It's that one. Yep.
Okay, which part of this are we not finished?
Mostly some name changes we've gone through, fitted process, simulate, etc. This is to deal with things where you have an arbitrary process in the first argument, and it's going to try to fit that process you name to the data. So we talked about this as a design option we wanted it to do. So this is calling this fitted process simulate is a new proposal because we're fitting the process you give to the kind of data you gave us. And it's
I
going to have,
understand. So
yep.
what's the analog of this in time series?
So there is no direct analog on this time series. There is time series forecast, but it's kind of narrow definition.
You also could do it in two steps with like find process parameters and then simulate functions. But
right. So this is equivalent of like estimated process or find process parameters and then a random function on that
yes.
model.
Okay, well, so that should work then. If this is going to work.
Well, time series forecast was using time series models at the time.
I understand. Time series forecast is just for like the ARIMA models. It's not general for every process.
Well, okay, but
it's for time series models,
right?
Okay,
fair.
So
okay. That's a name that's used.
Yeah, right. I understand. But so what's happening is you could get that process from estimated. What do we call it?
Estimated process.
Estimated process or find process parameters.
Okay, so time series for, I mean, this could be time series forecast of estimated process of the old time series. Is that right? Or of the data?
I would say that it would be more likely the time series model fit because this is narrowed for the time series processes. This is a computation, not the simulation, and it's defined for the ARMA SARIMA family of processes.
So those things, Stephen, those are called time series. Those are basically stochastic difference equations. That family of things. But we didn't have a thing called time series for data. So in the literature, for econometrics, when they say time series models, they think of these things.
Yes.
Okay. But this now is a little bit confusing because we have time series as a data thing. So the time series here refers to the models.
But it's applying it to a time series data object here, right?
Yes.
So it's forecasting that time series with this kind of process, which is a time series process.
Right. And that forecast is like, or that predictor is as everything, it's the conditional mean given the history.
Yeah.
Yeah, and this is going to be conditional means rather than give you a population sample, whereas fitted process simulate is not restricted to the finite differences models, and it's also going to do a multi-prong simulation, right? 500 or another if you give it that, and your other things about means and medians, et cetera, are going to be calculated off that simulated sample.
I think you want
you
want a whole slew of things that you can check on afterwards, like diagnostics and.
What is fitted process data? Is that a new thing?
Yes, this is a new head that's a wrapper around the time series data payload, as well as some other information, like what did it find as the process parameters when it fitted it, et cetera.
But that's also a thing.
This is very lightweight. It doesn't produce any big thing like that. It's very bare bones.
I understand, but what is estimated process returning?
This returns it's like estimated distribution. It just gives you the process with the parameters filled in.
Yep.
So unlike something like predict, which returns a predictor function, right?
Yes.
This returns only a semi-symbolically specified process descriptor, right? Here.
It returns values.
No. The forecast returns values, but estimated process returns an ARMA process, right?
Yes.
Yes. The time series model fit would have more information.
This is the bridge between data and models that we created. We can create this deeper bridges that provides for diagnostics and all, model selection, all kinds of other things. But
okay, but one of the things that you want here is this is really a Monte Carlo. But now in temporal data, is there some kind of Monte Carlo thing that you can get out of temporal data?
some temporal data was designed to provide a container for simulations or data that you collect. And those are ensembles of data. So there are many paths. If you think of a process, it's not just a one-shot thing. It's like an infinity of paths or realizations. And so temporal data contains that ensemble. And you can think of it, you can deal with it as one object.
Right, but can you get, I mean, in this case, you're simulating X number of paths.
Yeah.
Can you get that out of temporal data or not?
Yeah. Yeah, this one, the first example there simulates one path, just says over what time horizon. 0 to 100.
Which one? Sorry.
The first example there. Random function. Random function is the one that simulates things. Estimating, it estimates things.
Yeah, so if you had random function with an extra argument, you could get a sample.
So how do I get those? If I do tabular on that, do I get that as a
I think you might have to do, okay, in the case, automatically works. If you want more control, there's 2 tabular.
Yeah. Okay, so if I had said here, how many paths? Does it have a third argument with number of paths?
Yeah, third argument, if say 100, you will get 100 paths.
They're sampled at different times?
Yes, because
it's a Poisson process.
So the time between events is a random variable, an exponential.
In this particular process, yeah, in this particular process.
For this process.
But now, in what you're doing here, you want to always share the times. True statement
Correct.
or not?
Correct.
Yes, because they use different models.
We're forcing a uniform time step.
Okay.
You can't do that in general for random processes.
Right.
Well, are we locking ourselves
it,
in somehow by making that assumption here?
Yes, in the sense that there's some processes you would have to approximate if you. The same is true. The same is true for like things like step sizes. Like we will do something here where if you tell it you want a random walk, it will take an average of the differences in the data to use as its step size, even though that's only going to give you an approximation. You can force the data you have to be approximated by a process that doesn't share all the characteristics of the data, right?
Yeah,
You're just going to get a cruder fit.
Okay, here's a question. In fitted model, right? What if I say model fit? Okay, so that's the analog of saying a REMA process or something like this. Is that correct?
Yes,
but what's the general? Yeah, go ahead.
Model fit, when you fit temporal data, you want to go back in time. Model fit does not. If time is a column, it doesn't go back in time. It just for that time only. You know what I'm saying?
I'm thinking about the term data here. I don't think it's really right. This is really a fitted process, is it not?
Well, it's a little bit of everything there, sounds me.
No, because it has both. It has the model that it found for the information, and then it has the
data,
ensembles that it simulated according to the model that it found.
Right. So it's not just the table of the data of the paths. It's also got, the extra memoized stuff at the top, whatever, the extra metadata at the top that tells you these are the parameters we found for the fit, etc.
So it does it's kind of doing two things in one step.
I hate
and
that.
then
That'll
storing the
be
things
a
inside.
mistake, guys. It'll be a mistake. Almost certainly. I mean, unless the only thing you want to do,
I mean, it depends, Stephen. This is also how you get more efficient workflows. So, but then you can sort of, it might be too constraining, as you're probably thinking. But the counterpoint is that, well, then you have to do it yourself in 2 steps.
Yeah, and you can absolutely do it in 2 steps. I mean, you can go use find process parameters on your data to figure out what you want the process to be, and you can put that process into the first argument, right, or whatever. You don't have to do these in 1 step, but it's designed in 1 step because a lot of the common things we want to do
all right.
are simple.
Okay, so here, this is the destination date that we want to reach, and this is the number of paths. Is that correct?
Yes, that's correct.
It'll probably be okay. Roger, do you have any further comments on this?
No, we've spent quite a bit of time with Filippo, and I've been looking at sort of ensembles more generally outside of stochastics because it occurs many places, and we are starting to introduce it broadly in other areas for differential equations and systems and whatnot. And
So I don't quite know what you mean by ensembles, because I mean there's this whole multi thing that is ensembles relevant for computation.
Yeah, I mean like temporal data where it has many trajectories, like a collection of time series.
Okay.
But in one
many
object.
realizations, and the point is those
many realizations.
They don't have to be in the time domain. They could be in a space domain as well, etc.
Well, that leads to a whole other set of problems. But yes. But the thing is that when you broaden the view of what those things are and how you use them, I think that one has to have the flexibility of having not shared time steps. One has to have, I don't even know fully what all the workflows are that follow this. I've sketched a bunch of things that we can do.
Well, if this is a fairly opaque container, it probably does not have to forever have shared time steps.
True. But also, I just think that as a general system object, I think that this shouldn't be. I mean, I think it's in the finance framework. It fits great.
No. We want to make something that's general.
Well, it isn't.
What are we going to do?
I mean, it isn't. It's for this use case.
Well, but that's not what we're trying to design. That's not, I mean, by the time I'm involved in these design
But then you
reviews,
need to have use cases that show how it comes into other cases, and they don't.
Let's be clear. I mean, there does need to be some understanding of what the forward design path is for these things not being in just a finance framework add-on thing, but when these things are actually kernelized, and we do want Stephen's input on that, but we don't have to necessarily have a design for the finance framework itself that is, fully future compatible, or we will not be able to ship this until 15.1, etc. We do need something for the actual finance framework, right? But I agree with that. There does need to be some path forward for these things to converge and be nice kernelized functions. They don't have to be kernelized functions today.
Yeah, but Roger, so this looks reasonably sensible to me. I can't guarantee it completely, but
I mean, it's a corner thing. It's not the general ensemble case. Let's be real. It's not. It's not even close.
Yeah, because it's not letting times be arbitrary across things, and
among other
put
things
into a table and so forth.
Yeah, and there's a gazillion other workflows that come around it that's not even talked about here. So it's not even close to the whole ensemble case. But what it could be done, it could augment random processes, in which case it actually is kind of a useful and beautiful thing. It's not a revolution, but it's nice, and it's particularly nice, in the finance framework.
So if we did that.
But now you need to make predict, actually you only simulate it. You don't predict anything. Yeah, you only simulate it. You don't predict anything.
Something else.
Yep.
That will work for any process. as long as you allow for arbitrary time steps.
Okay. So just think through how the arbitrary time steps works, although we don't have to implement it right now. Okay, so then here, looks nice enough. So now we've got fitted process plot. That seems okay. And we can imagine things which aren't time series. I'm not sure that this, I'm not sure we want the legend by default. Am I making sense?
I understand. You might want to, if legend is on and or something like that as an option.
Yes. I mean, see how, I mean, legend did arrow automatic or something. What is plot legend arrow automatic? Would give that legend, but don't have it by default because it's kind of, you know.
Yep, understood. That's easy.
That's just truncating it to that time range. Is that correct?
Yeah, where
yes, it's giving only the future, right? Not the past.
Yeah.
I think it's okay.
And this is just showing that you can do things where you're doing the sort differently, right? You can have a sort function. Well, when you're getting this, this is showing you a median path where it's median by the ending value. You also have a median path by the total over the whole path.
That's a detailed thing. For goodness sake, don't make that the second argument.
Okay.
Okay, understood. The idea here was a sort function of the second argument. We can decide where to put it.
Yeah. Got it.
Well,
but you do have to have some notion of how you're sorting your sample for things.
I understand, but this particular thing about a fitted, this kind of plot. I mean, Roger, this is like distribution chart, but it isn't distribution chart, right? This is a useful kind of plot in general, isn't it? That shows the bands of, you know,
yeah, Roger's on mute.
Okay, so Roger, okay. You know, this seems like a generally useful thing.
If we have Roger.
I think we lost.
We need Roger for this. I have to go in 5 minutes, so.
I understand. The thing below this was we already looked at it for versions of it, but being able to have the
I'm going to say,
quantiles.
and this for Gosha and others, and Roger should be here. You know, this is a general kind of chart, right? It's like distribution chart, so we need it. You know,
yeah, I mean, yeah, it does make sense. And then we have the different ways of sorting, you know, of looking at the quantiles in the paths.
But the point is that doesn't have to be on a fitted process. It could be on anything else which is producing a multipath sample.
Yeah, exactly. So yeah, I brought that up earlier in the week. We didn't build it at the time, but if we're going to support ensembles more, so this is a general thing for ensembles.
Yeah, right. And so
not only these ones,
right? So. But I mean, so probably a list of lists where each sublist is a set of data points that is a distribution like this, or I don't know. Well, that's where it could be a list of XY pairs, a list of lists of XY pairs. See what I'm saying?
Yeah, you can certainly have multi-dimensional versions.
Look at all the inputs for temporal data, and you get your catalog of cases.
Okay. All right, fine. But then this thing should be called some kind of quantile. I mean, this is really, you know, a quantile chart or something. You know what I'm saying?
Yeah.
The fitted process quantile down below is meant to be not just a default set of paths, but give you control over which ones you want. But
that was a very specialized case of picking out the quantiles that you're sorting through the multipath.
Right. So if you want exactly the 75th quantile path or the the 60th quantile path with a certain
Well,
sort
that's the
function.
thing you should be able to extract from fitted process data.
Exactly. This is just doing it for you.
I see. It's getting a single path out,
Yes.
just getting
as many paths you want, as many quantile you define.
But presumably what it's doing is
so you can give it a sort function. You can, if you say automatic, it's going to get you the standard 5 of 5, 25th, 50th, etc. But you can also give it a list of the quantiles you want. But whatever it's doing there, it's extracting those specific paths from the distribution.
Right. So the sorting function, the third argument, is basically assigning a single value to each path, and then sorting, getting the quantiles based on this univariate data.
this is bonkers. What's happening here? I mean, this is something. Okay.
That's a path. I mean, but
No, it's not a path.
It's an association.
Where
It's
an association
of
which
labels
has
goes to
quantile
paths.
values, and it's like saying, I mean, we could do this just for a random, a bunch
Correct.
of random numbers. We could say, right now we have, if I just say, random real 10, 100, and I say quantile. I mean, right now the way this works is I say quantile of blah, comma, 0.7 or something, right? Or I could say here, quartiles of this, in which case it'll give me those quartiles without annotation.
Mm-hmm.
But also, in general, if you want to, this is a particular way of picking out a particular path in an ensemble. And it picks it by looking at a particular point in time and the value. But you could imagine many more ways of selecting one or picking one.
Yeah, and it doesn't have to be a particular point in time. It can be if you use last or something, but it can also be any function over the path.
Okay, well, that's much more general, because then you can sort of...
Right, like average, the most common ones in finance are last and average, but there's other things you can use it. You can do with it, right?
Mm-hmm.
If you put any pure function there as your sort function.
Mm-hmm. But this thing of picking, selecting, picking, I mean, you could program it today, obviously, but I think that that's a thing to make.
Yeah, the real question here, I think, from your design point of view, is do you want these things labeled like this in an association, or do you just want the things returned, the individual things returned?
I think they should just be returned. I mean, I think it should be like quantile, right? I mean, why not just use quantile? Why not just say quantile of fitted process data, comma 0.7? It will return the 0.7th quantile of the time series.
Quantile does not take a function or operate on paths right now.
No, I know, but what I'm suggesting is that what it does is you say quantile of fitted process data. Now I admit, comma 0.7, and then that returns a time series. You can do the same thing with temporal.
And the sorting.
The definition, it's not clear. Do you want this to be, for each slice, or do you want this pathwise? So we can have a quantile for each slice of the data. And so you can have, imagine that you have, have a distribution for each timestamp.
Yeah.
And so you can have the quantile, at each timestamp.
I understand.
So
right.
that's two different directions. Yeah.
So that's why it just cannot be quantile, because it's understood that way. And
right,
if we do the time series map,
this orange curve
here,
presumably is that thing. Is that right? Is the slice quantile?
Yes.
Yeah.
Mm-hmm.
I'm sorry, the orange thing is not the slice quantile. The orange thing there is the median quantile by total. So the sort function is total, and then you get the median quantile.
I could also have a slice quantile, which will be another thing that will look basically like that.
You could change your sort function to find the one where it's part a certain timestamp.
Yeah.
We're at time, but
yeah, I know. And so look, this quantile thing. Yeah, go ahead.
I was going to say, I mean, I think we're close to finishing up this piece of it. There's the extra things we didn't get to today that we can push to next time, or things where we might need changes to kernel functions for the financial framework, and then different visualizations. So, but the kernel function extensions, some of those we've already talked about, things like mortgage being added, cash flow taking new kinds of time series objects.
Does mortgage already exist?
No. right now you can get the same functionality, but you have to use this annuity do in the time value functions. So making a nice wrapper function for mortgage that does the same kind of calculations, but is what people are expecting for a mortgage function, more like an alpha, is what this is.
Okay, but so you need to make a specific proposal for what to do with time value. If you're proposing that we generalize time value,
it's cash flow down belief that's going to cash flow is the thing which is now that needs to be sort of time seriesized, and then time value can just work on it.
Okay, so cash flow should be able to take a time series.
Correct. And the thing we actually need for is it being able to take time series of interest rates as well for swaps. That's the extension needed to time value. But these are straightforward extensions. But the point is, the existing function cash flow is not designed with modern time series.
So why don't you put in up values for what you're proposing now?
It's basically we basically have functions to already do all this stuff in the finance framework. It's just that they're extensions to kernel functions. And one of the things we wanted to identify was all the places where we touch kernel functions that should just be kernel functions changed, not our functions.
Yes, I understand that, but for practicality, you can define an up value.
That's what we're doing.
Just overwrite it. Yeah. Okay, fine.
Yeah, the finance framework doesn't need any of these changes in order to work. It's just these are the things we want to port into the next 15.1.
Fine.
Yeah.
And there's a few other things like that, like extensions to units. We need things like a contract as a unit for things that happens with futures to know that like one futures contract is 1,000 barrels of oil or 42,000 gallons of gasoline and those sorts of things.
I don't understand. Just quantity, one contract, that doesn't make sense. I mean, if it's a contract, this is an abuse of the notion of a unit.
So what's the right way to do it? Because we need to be able to units math on these things in order to translate between these futures contracts and how many dollars.
Well, I understand, but isn't it an oil contract or something, or a oil future contract? I mean, isn't that the unit should be? Okay, so here's the point. I mean, it's like we could define. Okay, this is.
If you did it that way, you'd have as many. You would have as many as you have tickers, and we have thousands of them. So
right. Okay, so this is a way of saying, just like we have $7, right? 7 yen, whatever it is, right? Then this is like saying you have. The point is that in the case of 7 yen, the 7 is just a number. And the yen is effectively the unit.
Correct.
Okay. So what we're talking about here is just like we have currency,
and we already have shares. We already have shares as a notion in the unit system, which is the closest thing.
Okay.
But
if that works, then we're in good shape. But the statement one contract equals one, quantity 10,000 barrels, that can't work.
It's not that statement. We need obviously a data object that's going to use that inside the wrapper functions that are working with the futures data, right? When we want the thing that you're seeing there to be like a property of the particular contract you've looked up, right? But we need to do this in order to be able to use the unit system to get the conversions correct as you go through all the different chains of things and put things together in the same portfolio. You have to be able to reduce to dollars and so on. So it's just a few patches needed to things which are currently not there in the unit system, and the rest of it we'll do in the helper functions that stand between the external data feeds and the mathematical expressions.
Yeah. Okay. Well, so I mean, if it works for shares, it'll work for contracts too.
That's the idea.
Just to extend it.
Yeah, that's the proposal.
Right. How can it work for? I'm so confused. Isn't it like there are different kinds of shares?
Yes, but if you have a ticker and those shares, the data function itself will tell you how to get from one to the other because it will have units in it. It will have dollars per share, and then dollars per share times the number of shares will get you dollars. So if you get something from a data feed that's in dollars per share and that's Microsoft dollars per share, you know that it's about Microsoft because that's the thing you asked for. But the fact that you have a unit in dollars per share will let you translate to dollars, which you can put together with something else which wasn't in shares. It was in cash in dollars or futures contracts in 42,000 gallons of gasoline and whatever. You can put them all into go through unit conversions to put them all in the same numeraire on the same basis, which you have to be able to do for portfolio if you're going to have what percentage of it is in this and what percentage is in that. Okay,
I'm losing it because I've got to pay attention to something else.
I understand. The other thing that's set for next time is just things about visualizations, custom visualizations.
All right. This is
Some of which you've
good.
seen before,
Yeah.
but we deferred the final review of them. So
Yeah, this thing will get updated for the next time.
Okay. And in terms of these things, you've had graphic design reviews
Yes.
for these things?
Yes.
yes.
Yeah.
All right. Sounds good. All right. Look forward to seeing all this stuff.
All right.
Okay.
Thank you.
Thank
Okay.
you.
See you later. Yeah.
Bye.